And here we go on our last page of our review for today. So for all of these, we have examples of a composite denominator. Notice there is a radical in each one. And our method here was to multiply something by something we called the conjugate. Notice I've added parentheses to help me remember. Since this is a binomial both top and bottom, this reminds me I'm going to have to use FOIL here. So job one is to try to remember what in the world is the conjugate. And for that one, we simply copied the numbers beginning and end. And what made it was the conjugate is the symbol in the middle is different. So again, this was a salt and pepper matched pair. And again, when I multiply the bottom of a fraction by something, I must also multiply the top by that same something. So here is our setup, and each of these will work in a very similar way. To get the denominator to turn into a whole number, I need to multiply by the conjugate in all of these practice examples. Now, when we choose something like this for the denominator, this allows us to employ a shortcut. All conjugates will work this way. We've seen this before. Instead of actually doing all of FOIL, all I need to do is square that first number, write a subtraction symbol, and square the second number. So this denominator here becomes 25 minus the square root of 3 squared is 3. So that's how this one's going to start to work out. Up above, I do not have such a nice occurrence. So let me finish this. This will be 22 for my denominator. Up above, I am required to FOIL. So I'm going to, for up above one, I'll do that in red actually. The numerator, f is 25, 5 times 5. The O part is 5 times the square root of 3. Inside values, square root of 3 times 5 is once again 5 square root of 3. And square root of 3 times square root of 3 is still regular 3, square root of 9 actually, but we can write the 3 immediately. Notice here I have 25 and 3 can be brought together as a single term, and these two remaining guys are also like terms. The radicals match beautifully. Notice I just kind of copy that radical there. I do not multiply it together because I'm not multiplying here, I am adding. Going back up top and finding my denominator from previous work, here's what I have. You might think that looks pretty good. However, notice each of the numbers that are regular real numbers, so the stuff that is not under the radicals, each of those are even. So those can be reduced and should be reduced. Dividing by 2, I get 14 and 5 and 22, and don't forget the square root of 3 was attached there. So notice I do not end up dividing any of these by 4, I just use the 2, but the numerator, each of them has to be divided by the single 2 from the denominator. So there is your first problem, there is your solution. For our second problem, once again, you want to add your parentheses. This works in a very similar fashion to the other one. So again, job one, pardon me, is to select your conjugate. Let's parenthesis that guy too. I'm hoping we're not falling off your screen there. That might be a little better. And now we said down below, because of the nature of the conjugate, 2 squared is 4, and I got to square my last one, and there's always a minus sign here. Square root of 3 times square root of 3 is regular 3. So in this case, we get a very nice denominator of 1. A student earlier asked if we always will get that 1. I think we saw in question 1 here that no, we do not always get a 1 down below. We always will get a rational number though. Up above once again, and I will come down the page a ways for this one. Up above we are required to FOIL because there is no matching type of shortcut situation. So 3 times 2 is 6, that's the F part of FOIL. Outside is 3 times negative square root of 3. The insides, it's also one of those two parts are negative. So 2 times the square root of 6, we usually write that whole number first. And lastly, negative square root of 6 times negative square root of 3 will be a positive square root of 18. Now looking at that last number, I can do a little bit of work here, right? 18 is 3 times 3 times 2. So I can actually turn this into 3 square root of 2 pretty nicely. My other terms, as I'm looking for matching radicals, I do not see any radicals that match. Can I simplify any of them? Well, this guy here with the 6, I could factor that into 2 times 3, but I still do not have any groups of 2 to factor out the front. So in this case, my denominator ended up being 1. My numerator had 4 different uncombinable terms. So this will be our final answer for number 2. And lastly, for number 3, one more iteration of the same process. 7 plus square root of 45. Again, multiply the numerator by the same value. Helpful to write it in parentheses. And we have our shortcut on the bottom. 7 times 7 is 49, minus square root of 45 times square root of 45 is 45. Here I happen to get a denominator remainder of 4. I will put that out there and hold that for later. And now I work on my numerator. I'll make a temporary fraction bar there. 10 times 7 for FOIL is 70. 10 times square root of 45. Negative square root of 11 times 7. And lastly, negative square root of 11 times a positive 45. I'm just going to write that this way for now. If I have to multiply it out in a minute, I will. So, is there anything to combine? I see I'm probably not going to have any like radicals. However, check out the square root of 45. I think we all realize that 45 is made up of 9 times 5, and the square root of 9 is actually a nice number 3. So that 3 will come out front and actually combine with the 10 that's already there. So this 9 turns into a 3. 3 times 10, who's already parked over there, is 30. And now what's left? Just the square root of 5 from right here. The next value, negative 7 times square root of 11, I can't do a thing with. 11 has no factors. On the end, here's that 45 again. So that will generate a, from 9 times 5, that'll generate a 3 out front, still negative. And what is left? The 11 that was there plus the 5 from my factored 45. So square root of 55. And it looks like things are now in lowest terms. Once again, I have a larger answer. I do not wish to divide anything by 2. I see that the 70, the 30, divide by 2, so does my denominator. But the 7 and the 3 that remain do not. So therefore I cannot have those be factored any further. That'll bring us to the end of this problem and to the chapter review. Good luck on your summative tomorrow.